All right, so we are going to be looking at a brand new coordinate system. And our coordinate system here is going to take any point in normal xy and change it to be the angle from the x-axis through some angle theta here. And then that point, since it's not infinite, that point is the distance to the origin, which we're going to call r. Now, if you were to use just normal trig here, then the cosine of theta would be x over r, and the sine of theta would be y over r. And so notice down here we say that x is then r cosine and y is r sine. And because of the unit circle and just circles in general, we know x squared plus y squared is going to be r squared. And then also the other trig that we would know here is that tangent must be y over x, right? So kind of using some of these thoughts from unit circles in order to define these polar coordinates. And so let's look at some examples here. If I'm looking at the point 1, 1, if I were to drop that down, 1, 1, 1 squared would be equal to r squared, right? And so r is going to end up being the square root of 2. Now you might notice this also as the unit circle triangle that like I've taught in my pre-cal classes where it's the isosceles. And so that theta is going to be pi over 4. If you didn't know that, then you'd want to look at like, okay, when is tangent equal to 1 over 1? And then use arc tangent in order to find that. So we say that r is square root of 2 and theta is pi over 4. And that is how we're going to then figure out where this piece is in polar coordinates. Okay, so converting xy to polar coordinates. We can also write this as our theta ordered pair, like that. All right, let's go ahead and look at our next one. All right, -3, 4. So again, if I think about what is r going to be, I know that x squared plus y squared equals r squared. And so this is going to end up being for r the square root of 3 squared plus 4 squared. If you notice that is Pythagorean triple, so r is going to be 5. Unfortunately, this is not a nice theta value. Now, we do use theta as being this piece right here. And so we have, let's see, opposite is 4. And then adjacent is -3. So the tangent of that theta needs to be -4 thirds. We would probably want to use a graphing calculator or a scientific calculator to take the arctan of that. And we do end up getting that theta is approximately 2.21 radians. Okay, but it's not like a nice unit circle piece there. And so that's going to be our answers for B. Let's look at C. Okay, for C, if I'm at the point 0, 3, all right, well, R is going to be 3. And then that angle of theta is going to be pi over 2. So anytime I'm on the axes, those are going to be nice pi, pi over 2, 3 pi over 2, anything like that. And then your radius is going to be that length along the axis piece from the point to the origin, right? All right, last one here. If I am at 5 root 3 negative 5, I know I'm in the fourth quadrant. 5 times the square root of 3, that's going to be a little bit bigger than negative 5, just as a value. Okay, where this height is 5. 5 root 3 is here. So let's think about what this hypotenuse is going to be. Well, this seems really similar to like root 3 and 1 and like Pythagorean or special right triangle triples is what I'm trying to think about here. So if I go back to like this is side A and this is side 2A, and so this is A root 3, then this angle must be a 30-degree angle, and this is a 30, 60, 90. And so if this is length A based on my similar figures or like my expansion kind of the unit circle, then 2A means that my radius must be 10. Now, could you say 5 squared plus 5 root 3 squared? Square root, yes, you're going to get 100 inside the square root. You're going to get 10, but R being 10 also comes from that being a special right triangle, a 30, 60, 90 triangle. And because this is a 30, 60, 90 triangle, we can say that that theta, then let's see, all the way around, it's a 30 degrees. So it would be a pi over 6. So all the way around would be 12 pi over 6. So I would say this is 11 pi over 6 or negative pi over 6. Like either one of those would be okay to use here. All right, let's look at going the other way. So if I know that R equals 3 and theta is equal to pi over 3, so this is 3 and my angle is pi over 3. Okay, so again, going back to that 30, 60, 90 triangle piece here, across from the 30-degree angle is going to be my A. So this is my 2A and this is A square root of 3. And so this length has to be half that radius. So this has to be 3 over 2. And then this has to be 3 root 3 over 2. Another way to look at this too is if you know your unit circle, this now has a radius of 3 instead of 1, so you can take this point, which would have been 1/2 root 3 over 2 on your unit circle, and then like, oh, but I need my radius to be 3 times as much. So multiply that by 3, and that would find you your xy. Let's go ahead and just jump down here to this last one. Or let's actually do F, okay? And then we have a couple more examples to look at here. But let's say I'm at 2 and then 3 pi over 2. So radius of 2, but at 3 pi over 2. Well, that's the point 0, negative 2. Okay, so that's how we transfer back and forth between these. Knowing your unit circle and knowing those special right triangles are going to be really, really important to figure out these angles. All right, so now let's plot these on the polar coordinate system. So if I'm looking at the point 2 and then pi over 4, that's going to be this point right here. All right, negative 3, 2 pi over 3. Now, when our radius is negative, what ends up happening is you go to 2 pi over 3, 1, 2, 3, but then you negate it the complete opposite way. 1, 2, 3 is that point there. All right, let's look at 4 and then 5 pi over 4. So go to 5 pi over 4, count out 1, 2, 3, 4, and that's my point for 5 pi over 4. All right, so now we have our last set of examples. The first one here, if I have theta equals pi over 3, then my radius with that one is infinite. So I'm just looking at this line that goes from the origin along this angle of pi over 3. If I'm looking at r equals 3, then I'm looking at the circle all the way around, because theta is now infinite, where this is now a radius of 3. All right, our last one here is going to take a little bit of some mathemagic, okay? So if I had r equals 6 cosine theta minus 8 sine theta. Now remember that we know x squared plus y squared equals r squared. And that's a circle centered at 0, 0 with radius r, right? We also know that x is equal to r cosine theta and y is equal to r sine theta. Okay, those were some of the identities we looked at the very beginning of this video. So if I multiply everything through by r, just by r, then I'm going to get r squared is equal to 6r cosine theta minus 8r sine theta. And that then tells me that because r squared is x squared plus y squared, I can substitute that in. And since r cosine is 6, I can substitute that in. And r sine is y, I can substitute this in. Let's go ahead and move those over. So x squared minus 6x plus y squared plus 8y is equal to 0. Now I'm going to complete the square for each one of these. So x squared, x plus something, plus y squared plus 8y plus something. And then I need to be able to add the same thing on both sides since this is an equation. So 6 divided by 2, 3, square that is 9. And I end up with x minus 3 squared here. Half of 8 squared is 16. And I end up with y plus 4 squared equals 25. So when we talked about circles before, we have x squared plus y squared equals r squared. That's centered at 0, 0. If you think about like shifts of our functions, since 3 and 4 are inside the parentheses, this means my center must be at 3, negative 4. And the square root of 25 means that r must be 5. And so this is a circle centered at 3, negative 4 with a radius of 5.